Good morning, everyone, and very warm welcome to you all to today's webinar on collaborative R&D. R&D is one of the most intrinsic arms of the industry today and extremely vital to its growth. There is little doubt that industries that have invested in these all-important functions have experienced immense growth. Such investments have been foundational not only to the growth of the individual businesses, but continuous investment in R&D has enhanced the quality of life as well. In just past few months, the world has witnessed how R&D has proved to be a lifesaver. All around us, we are seeing fabulous advancement in the field of polymers, from new materials, life-saving polymer chips to deliver vaccines, antiviral polymers, and much more. The advancement of applied science is reaching places which we have never imagined before. Today, we have with us two eminent experts, a distinguished scientist, and a leading manufacturers of Masterbatches are here to discuss the need for greater collaborations between the academic world and the industry. Now, I would like to welcome our chairman, Sri Arvind Goenkaji, to share a few words about today's session and also introduce the eminent speakers. Over to Chairman, sir.
Thank you very much, Shivaji. Good morning, friends. Good morning, and everyone, a very warm welcome to this morning session on collaborative R&D. As we know, universities are centers for skill development and academic learning with the primary objective of educating students and stimulating analytical and revolutionary thinking. Today, we have numerous prestigious research universities around the world that allocate a significant portion of resources and funding towards research beyond imparting education. On the other hand, rather than investing in independent experimental research, a corporation's R&D resources are generally limited to a specific field of products, and often they opt to concentrate their budgets on profit-driven applied research, where priority is given to product-specific projects and with results such as pinpointing target consumer needs and market trends. However different in their fundamental objectives they may be, today we live in times that make it perfect for different types of organizations to establish synergies and emerge as the perfect partners for collaboration. This makes the perfect setting for collaborative R&D. When it comes to R&D, both sides must actively work to bridge the gap for a successful partnership, as external collaboration comes with undeniable merits. External partners collaboration promotes innovation by giving access to a vast pool of global talent, knowledge, and expertise with maximizing benefits for both. Please join me in welcoming Senior Principal Scientist at the National Chemical Laboratory, Dr. Samir Chikkali. Dr. Samir Chikkali recently received the 10th National Award for Technology Innovation in the category of Innovation in Polymeric Materials for his work on disentangled ultra-high molecular weight polyethylene from the Department of Chemicals and Petrochemicals. An eminent member of the global academic circles, Dr. Chikkali obtained his PhD from the University of Stuttgart, Germany, and subsequently did his postdoctoral research at the University of Amsterdam, Netherlands, and the University of Constance, Germany. In 2012, he joined CSIR-NCL to start his independent research career. Dr. Chikkali has received several international awards for his work, authored more than 55 research papers in international peer-reviewed journals. Besides, he has filed 15 patents in India and abroad. Currently, he leads a team of 12 researchers in polyolefins, organometallics, and renewable degradable polymers at NCL. Friends, it also gives me great pleasure to welcome Mr. Vikram Bhadauria, Managing Director, Alok. Well-respected member of our industry, Vikramji is a well-known name in the plastic today. He is also Plex Council's regional chairman for the northern region and has been contributing tirelessly towards plastics export promotion. His company Alok Masterbatches had established its own innovation lab, Alok Technology Incubation Center, in 2015 in Delhi, with the objective of making customized future-ready solutions for the evolving needs of the plastic industry. ATIC has witnessed co-creation of several specialty solutions which find diverse use in day-to-day applications. In 2019, Alok won the Golden Peacock Eco Innovation Award for UV Nox mulch, a solution developed at his innovation lab, ATIC, for the agriculture sector. This indigenously developed solution, created in line with the Prime Minister's vision of doubling farmers' income, makes mulch films 40% affordable and significantly more durable, which in turn help farmers increase their yield. He believes that given the focus on value-added sustainable solutions, innovations will be the key in resolving the most pertinent issues across sectors. It will serve as a catalyst to enable business growth in the in today's session, he talks about affordable technologies and the realm between Jugaad and the exotic. We we thank our esteemed speaker for their time today and look forward to an engaging session. Thank you very much. Over to Sribaji. Thank you. Sribaji, thank you.
Yeah, Dr. Chikkali, you can start your proceedings today.
Should I start the presentation?
Yeah, please.
Okay. At the outset, I would like to thank Council Chairman Sri Goenkaji for giving a nice introduction and introducing me. I think it's a pleasure to share some of my thoughts on bridging the gap between industry and academia with one example that I pursue in NCL. Let me just share the slides. Okay, is my screen visible?
Yes, Dr. Chikkali.
Okay. Yeah, very good morning to one and all. I'm Samir Chikkali, working in National Chemical Laboratory. In next 15 minutes, I will give you a brief idea about what I do and then what I feel about bridging the gap between industry and academia. Let me start with briefly giving an idea about what I do in NCL. Research Mining Group integrates various elements of ligand designing new catalyst for either olefin polymerization or for converting renewable monomers to polymers, so as to design a strategy to understand and address scientific puzzles of fundamental importance. We just don't stop at developing fundamental science, but we try to bridge or to take this fundamental science and address real world problems that we do with the help of industries. So we extensively collaborate with different industries and try to take this science that is developed in the lab and deliver solutions to the real world problems. Let me start with giving one example, which I think most of you are aware of, is polyethylene. It is a material which is about 60% of the total plastics produced today. And it has been developed way back by two gentlemen. One is Professor Ziegler. The other one is Professor Nata from Italy. I hope you are able to see the arrow. So this Professor Ziegler developed this in 1953. Before that, there was polyethylene. It is not that Ziegler was the first person to develop it, but before that, in 1933, ICI, Imperial Chemical Industry, developed a process which is called high pressure polyethylene process. And if you look at the parameters, at what parameter the process runs is 3000 bar pressure, 3000 bar pressure of ethylene at 400 degree. So this is the process developed by ICI, and it was a commercial process, and polyethylene was produced during Second World War using this process. So people knew that polyethylene has a lot of commercial significance, and they were trying to solve this problem, meaning looking at 3000 bar and 400 degrees is like sitting on a bomb, right? So Ziegler and many other researchers were looking at making polyethylene at milder conditions. And in 1953, Ziegler developed something called low pressure process, or it is called atmospheric ethylene process in Mülheim. So Professor Ziegler was a director of a Max Planck Institute in Mülheim, and what he developed is a catalyst actually to run the same polymerization but at less than 10 bar at 70 degree. Now using this process, today we produce about 180 million tons of polyolefins globally, And if you look at in India, we produce about 10 million tons of polyolefins in India. The process is well understood, and there are well set mechanisms. There are commercial licensors, and most of our processors, whether it is Indian Oil or Reliance or Haldia, they all license these processes from outside, which have been developed over the years from the work that Ziegler developed in 1950s. And these have reached scales and economies of scales which we cannot simply beat. Okay, so that's the reason why the Indian industry goes and license these technologies and just produce or manufacture it. Now, if you look at polyethylene, you can make humble carry bag, right? And you can actually tear off the carry bag with your hand. But the same polyethylene, if you can strengthen it, you can actually use it as a bulletproof jacket. So how can you do that? This is what I'm trying to do, and this is what the award was about, is to look at a polyethylene which is called ultra high molecular weight polyethylene. There are there are a lot of confusions. What is ultra high and so on. So I just cited here a definition that is provided by ASTM, which says that ultra-high molecular weight polyethylene can be defined as a linear polyethylene with viscosity average molecular weight larger than 2.5 million grams per mole. So any polyethylene which has this molecular weight or above can be classified as ultra-high. Now, once you make this, the polymer chains are so long, okay, they don't stay straight, but they try to fold and try to make knots. That is what I have shown on the right-hand side. This is a spaghetti. And if you look at spaghetti, they are not straight chains. They fold and they create knots, and you try to pull out one, the other comes. Okay. The problem with this polymer, you can make it, but you cannot melt process. Like your LDP or HDP, you just melt it and then you can process it through injection molding or extrusion. Okay. But this polymer, you cannot do that. This polymer decomposes before it melts. Okay. So how are the commercial players doing this? So there are mainly two commercial players. One is DSM, the Dutch company, and they have a grade called Dyneema. The other one is Honeywell, and they have a grade uh, uh, Spectra. So these are two basic grades. From these, there are many licensors who have licensed it, but these are the two. What they do is they dissolve this polymer, 5% polymer in 95% solvent at about 170 degree, and they make a gel. And then they do a gel spinning. They spin out fibers, and these fibers are used for example, in bulletproof jackets. So people started how to resolve this. I mean, you have only 5% polymer and 95% solvent at such a high temperature. Your processing plant becomes solvent recovery plant. Okay. So people started, okay, can you address this? Can you make this, can you solve these knots and make it disentangled? So what is disentangled is same ultra high, but now if you look at this, it is like polyethylene single crystal. That means you have one chain, there is no entanglement, and they are crystallized, and it's highly crystalline polyethylene. So if you have something like this, your processing becomes easier because now there are no more knots, and this can be molten. Okay, so this is the material we thought we can venture into, and we started looking at how these two materials are made globally. We found most of the commercial material that either ESM or Honeywell makes uses heterogeneous catalyst, the old Ziegler catalyst with different conditions, but they get entangled ultra high. There are very recent, from 2000 onwards, a couple of reports from Mitsui and some other company who use this homogeneous catalyst, okay, and they can make disentangled ultra high, okay. So we then thought, why is the problem? What is the problem with heterogeneous catalyst? Why it can't give disentangled? So we understood that it is because it is multi-site, whereas homogeneous is single site. Parameters are different, and the activities of the catalyst are different. So we question ourselves: can we reduce this in a controlled way so that heterogeneous catalyst also behaves like a single site catalyst, and the activities are comparable? That is what we did. For that, we had to do a lot of development. The figure on your left hand side is basically we developed a chamber to look at the oxidation state of the metal, which is the active catalyst. Okay, in Ziegler's system, it is known that titanium plus 3 is the active catalyst. And if you just take a generic Ziegler system, it has all titanium +4, +3, +2, 0, everything. And that's why it is multi-site and you don't get very good single-site catalyst in that. We looked at controlled reduction. We went from aluminum to titanium about 20 to about 600. We found that at 600, 99% it is titanium +3. That means this catalyst should behave like a single-site catalyst and should give us disentangled ultra high. Okay, we chose this combination of the catalyst and the co-catalyst, and we could get ultra high disentangled state. This is what you see. We have tried to benchmark with heterogeneous Ziegler system. What are the activities? What is the molecular weight? And we have also looked at homogeneous system. So if you compare with Ziegler system, our catalyst is much more active, gives 3 million molecular weight, and polydispersity is very low. If we compare with homogeneous, the chromium one, that is much more active than our system, but we get much better molecular weights and dispersities. We have been able to do this in a lab scale. I think somehow. Okay, so we have been able to do this in lab scale, and then we try to demonstrate or prove that we have a disentangled. How are you going to prove? There are different methods. This is the program we follow for a DSC method. And what you see here on your right-hand side is the high melting peak at about 140 is for disentangled state, whereas little lower melting about 134, that peak corresponds to entangled state. And as you can see, we do it at different hold time. And as we increase that time, the disentangled state goes back to entangled state. So this is what we have proven by DSC, by rheology, and many others. We have scaled this up to about 3 liters in our lab. We can make about 300 grams in one batch. We have filed Indian and patents outside. This is one of the US patents that we have. This we are discussing with many Indian petrochemical companies to license this. Now, what is the advantage of having disentangled? The advantage is this one that I was talking initially. If you take the entangled one, you have to follow this left-hand side process. That means you have to dissolve 5% in 95% solvent and push it through this extruder at very high temperatures and then spin a fiber. Whereas if we can get disentangled, you can do a solid state processing of this. So you actually earn a lot in terms of saving energies, and it's much more environmental friendly because you don't have to worry about these solvents. Now, this was about my research on ultra high. Little bit about industry and academia. Now, I would like to give you the same example, that Ziegler's example. When Ziegler started in 1952, okay, he gave a talk in GDSH, is a German Chemical Society. In Frankfurt, he gave a talk about using alkyl aluminiums to make high molecular weight polyethylene. It was not polyethylene, he called it as high molecular weight alkanes. Okay. Now there was a company attending the same conference, and that company goes back to Ziegler and says that we want to have access to the information. This is only access to information. That whatever is going on in your lab, we want to have some people sitting in your lab and trying to see what you are doing. Okay. For that, they signed an agreement in January 1953 with Ziegler, and they paid 600,000 Deutschmark. DM stands for Deutschmark in those days, which is almost equivalent to euro now. They paid 600,000 to Ziegler to just get access to his lab. Okay. Then they deployed 3 people from the company who stayed on in Max Planck at the cost of the company, and they just used to observe what Ziegler is doing, what his students are doing, how they are running, how they are making alkyl aluminiums, how they are making the catalyst, and how are they polymerizing it. Okay. Now in October 1953, Ziegler found that if he mixes alkyl aluminiums and titanium, he gets polyethylene. Okay. In October 1953. November 1953, he files a patent. I think my presentation is somehow being. Okay. So November, he filed a patent about his discovery, and within 3 years, the same company, about 3 to 4 years, the same company puts up a plant. Okay, this was not polyethylene. The plant was a polypropylene. There is little history to that. I think I'm not going to go into those details. This history, I have taken it from two websites. One, the Max Planck website. You can go to this website and you will find the history, what Ziegler did. The other one, Nata. Nata was again a person who shared a Nobel Prize with Ziegler for polyolefins. Okay, that is more about polypropylene, which we will not talk today. But Nata's children, they came together and they have a website in Nata's name, and all the information, including the data from the company, this contract with Ziegler, everything is available. Okay, so you can look at the engagement right from the early days when they did not even knew that Ziegler is going to make polyethylene. They signed a contract. Okay, and they just wanted to have access to his research findings. This has continued in the West. Even in 1990s, you look at Professor Brookhart's group in University of California in Chapel Hill, North Carolina in Chapel Hill. He has been generously supported by DuPont for years now. He has retired in 2014, but still is being supported by DuPont as an emeritus professor. So there is a deep connect between the industry and the academia in the West, which actually aces the path for the transformation from the laboratory to the industry. This is what is there for many of the successful technologies. It is little different for Indian context. Okay, so I will talk a little bit about what we face in India, both in terms of academia and when I go and talk to industry, what they have to say. In academia, we say that, oh, we are doing such a great research, we are publishing so many papers, but industry doesn't come and talk to us. Whereas the industry says, oh, the academia just publishes paper and they really don't solve the real world problems. Okay, I think the truth is in between. It is neither the academia that is too introvert or the industry who is not too generous. Okay, so the truth is in between. I have tried to show you the ladder from taking from the lab to the market or to a commercial level. When we look at laboratories or IITs or NCL for that matter, we are more focused on generating ideas, generating new concepts, for example, the ultra high, and how can we address a problem. But we also have to confess that we have a limitation. I can't be an industry. NCL can't be an industry. Why NCL was generated was to help India, to help industry, okay, not to become an industry. So there are industries that government supports, but the role of academic institution is to train manpower and generate ideas and give solutions, okay, not to become an industry. So this we have to understand, we meaning me as an academician or the professors at IITs, we have to understand and confess that as an academician, we have a limitation. We can generate nice ideas, we can solve problems, we can publish papers, but we can't deliver a product, okay? If a product has to be delivered, this lab findings have to be taken to industry. Okay, so there is in between a gap, and you can see on the arrow I have saying that this requires time, requires money, and then it reaches closer to reality. What we do in the lab is only in the lab. Okay, but if a product has to come, it has to go to industry, and the industry has to sell in the market to people. Okay. So what is required is that we have to bridge this gap between industry and academia. There should be deep engagement. Like I gave two examples, one Ziegler's example, the other one Brookhart's example, where the industry is actually involved right from the beginning, even without knowing what Ziegler is going to do or what Brookhart is going to do. Okay. Now I will share my personal example. I work with a lot of industries. I did a project for one petrochemical in India. We spent about 3 years. We developed a product on 50 gram scale. Okay. And then we said, okay, this is the process. Now you take it and you develop it. So then the industry sends 3 people to my lab. They were here for about 3 weeks looking at my student, what they are doing, how they are doing. They went back to the industry. They tried for 2 years, but they could not reproduce. And the industry came to me telling that, no, this doesn't work in our labs. Okay. Then finally, I suggested them better they hire my PhD students. Okay. They hired my PhD student and now it works in their labs as well. Okay, so what I'm trying to tell you is there is deep engagement required without worrying about too much about whether how much money has to be spent, our rules allow, our rules doesn't allow, what is allowed, what is not allowed. I think the focus, or there should be a champion who should drive this from both sides. From industry side, one champion is required to say that no, I can send the students or employees to the academia. And from academic side, there should be somebody who should say that, okay, although our rules may not allow us, but let them come and observe. Okay. So this is what I think we have to bridge. NCL does it in different ways. I'm trying to show how NCL try to work with different industries. One is that NCL has its own mandate. We are part of CSIR. CSIR is Council for Scientific and Industrial Research. Okay. And our mandate, the main mandate is to help the country. If the country is in problem, we have to rush and solve it. For example, the current pandemic, we have been developing many things for the country. And that is the first priority that we have. For example, NCL has deployed many technologies, even for oxygen generation. We have developed pressure swing technologies. We have installed in hospitals in Pune. We have given oxygen concentration based on membrane filtration technologies developed in NCL. Like that, CSIR has a mandate that it has to help the people of India. Okay, that's the first priority. Then the second priority is most of us academicians, we are driven by curiosity. We try to answer questions that we do not have answers to. Okay. So this we write proposals, we get funding from either different government organizations or from CSIR. For example, we can write proposals to DBT, Department of Biotechnology, Department of Renewable Energy. There are different government departments who launch calls. Ministry of Textiles is another one. So this is one part. So the protocols are very much set. How we work with CSIR projects, how we work with other government projects. I mean, what are our deals? That is fixed. Okay. Now the third part, which NCL is deeply engaged in, is with industries. Okay. What are the ways or what are the models that we work with? When the industry comes to us saying that, boss, we have this issue, we can't solve it by ourselves. Can you help us? Then we look at and try to see whether we have expertise in that area and how much time is taken. Usually, if it is between 1 to 3 years, we say that you do a sponsor project, that you have this problem, you define it, we will provide a solution to that. Okay. The other one usually is little long term, and NCL has been consistently doing this with many industries. For example, NCL had a 15-year agreement with GE. Okay, and NCL has agreement with Reliance from 1996, and it is still running. We renew it. Now, this agreement is basically defines what way we want to work with Reliance or what way we want to work with GE. And every problem they come up with can be taken it as a separate project. Okay. Now, there are a lot of other things, that is, we do consulting. If some industry just want our services because we have experts, or there are industries, for example, the Indian chemical industry is usually a batch process run. Okay, whatever processes we have developed are mostly batch process. So NCL used to run a consortium to convert all the batch processes to continuous processes. So this was a common problem, batch to continuous. And many industries came together saying that we want the same solution. So we formed a consortium and tried to give the solution to them. So these are different ways how NCL works. But for NCL, it is like a technology pipeline which should be always filled. So we need fundamental science, then we need proof of concept, then only something will come out as a technology. If we don't have fundamental science, the technology pipeline will dry up. Okay, so we need to keep doing on this side so that something comes out on the technology pipeline side. With this, I would like to thank my students who do all the work, and I do a lot of talking. I would like to thank the industries, CSIR, NCL, DST, Department of Science and Technology, industries who support my research. Thanks a lot for giving me opportunity. I will be happy to take questions.
Thank you, Dr. Chikkali. In fact, it is a nice presentation. Of course, it is there's a deep engagement is required between the industry and academia to take this innovation forward. In fact, we will be taking the questions, if any, from the members at the last after the presentation of Vikramji. If it is okay with you, Dr. Chikkali?
Yeah, sure.
Okay. Now I request Vikramji, please take it forward, please. Over to you, sir.
Great. Thank you, Shivaji. So, good afternoon, everyone. Pleased to be here. And thank you, Mr. Goenka, for the introduction that you gave. I'd like to mention here that the Alok Technology Incubation Center also won 2 national awards, one of them by the Prime Minister himself in 2017 for the research work that we have been doing. So, I truly believe that any interaction, any intelligent interaction, when it takes place, you should go away with a message. And I'll simplify the talk by giving you the 3 messages that I hope the audience goes away with. So one is a best-selling book that was written by Marshall Goldsmith, which says, "What got you here will not get you there." The second is, we won't achieve anything new tomorrow if we keep doing what we are doing yesterday. And the third is the blue ocean strategy. That blue ocean strategy was theorized by 2 professors from the INSEAD School of Business, and it talks about a competitive strategy that businesses and entrepreneurs should look for. So I hope by the end of this talk of mine that you'll have these 3 things in mind, that what got you here, what got us here will not get us further. And if we keep doing what we were doing yesterday, we should not expect different results tomorrow. And each of you can then look inside and look for your blue ocean strategy. So I'll start by the topic of the talk today, which is Jugaad. So what is Jugaad? May I request the administrator to please mute everyone else except me? Please, thank you. So Jugaad is, by definition, frugal innovation. And this is a terminology that we Indians, we've been hearing it since our childhood. But globally, it was popularized and romanticized by the Harvard Business School in the early 2000s as how a country used Jugaad to progress in absence of money, material. There was no access to technology, but still the country moved forward by Jugaad. And Jugaad has served us well till now. But as I said, what got us here will not get us there, get us further. So do we want to leave a legacy of Scotch tape legacy for the future generations? Or do we want to now improve upon it? Now that we have access to technology, we have access to money, we have access to all the things that 20 years ago were not possible in the country. So Jugaad, in a sense, is, you're on a permanent firefighting mode because it is not durable, it is not sustainable, things keep breaking down. Whereas what we need now to build a manufacturing, to build an industrial base is a sustainable and strong technologies. No nation in the world has progressed, has become a superpower without a strong industrial base. And that is true for us also. Whether you take Germany or Japan, who were devastated after the World War II, they again have come back to the top, amongst the top 5 nations, based on their massive industrialization base. So I'll start with the talk that over the past 20-25 years that I've spent in the industry, every entrepreneur, every businessman that I meet is always looking for a newer idea. Or aage kya karna hai? What else can I do besides what I'm doing? So by nature, it's in our DNA, in the Indian DNA, to be entrepreneurial, to look out for something new. We are never satisfied with what we have. So there is a drive, there is a zeal to do something new. On the other hand, if you see, we have 1 billion plus of population, but the goods that are being supplied, are being given to the population are not of international quality. They're not durable. They're all, we say sasta China ka maal hai. Chale to chand tak, nahi to sham tak. But China has built their own country, their own industrial base on very good products. And they have supplied to US, Europe, very good products on which they have progressed. So we need to have these technologies to give the Indian people, they want good durable technologies. All of us have access to now cell phones. Through cell phones, we have access to popular culture around the world. So the population has an aspirational aspiration to it, that I also want to live a better life. I also want better sanitation. I want better healthcare facilities. I want better household goods. I want better medical facilities. But on the other hand, we are not able to supply those. Either we give them the basic Jugaad technology that lasts for 6 to 8 months, or the exotic technologies which are imported from abroad, which are extremely expensive. So to give you a figure that, the purchasing power parity, the PPP of around 10,000 a month, we are not looking at deep pockets or highly disposable incomes in the Indian population. They cannot afford the pricey and exotic foreign technologies and have to make do with unreliable Jugaad technology. So there's a vast unoccupied space between these two poles, the expensive foreign technology and the non-durable Jugaad technology that exists today. This space has to be filled by the Indian entrepreneurs. And this is a vast, as I say, blue ocean. What is the blue ocean? We all are in a mega competitive, hyper competitive business scenario. So that's a red ocean. Everyone is cutting prices. Everyone is eyeing someone else's product, someone else's market, someone else's customers. So it's a bloody red ocean. A blue ocean is that of a calm where you have a competitive advantage, where you have relative peace. It's not so competitive. So this is the blue ocean that exists between the two poles, the high-end imported technologies and the low-end Jugaad technologies that we have currently. If we are able to fill this, there is a huge market for the Indian entrepreneurs and a huge opportunity for Indian businessmen. So now I come to the third. One was the entrepreneur, one was the Indian market, the Indian population. The third wheel on this juggernaut is the vast talent pool of engineers and researchers that we have in the country. It's an unrecognized asset, and I'd say underutilized asset also. So every year we are pushing out more than 1.5 million engineers and researchers from the country. This is more than the combined output of China and US. So the above mathematics is quite simple and encouraging. You have a vast aspirational population who's yearning for good quality products. You have a vast SME base and entrepreneurial base in the country. And you have this vast talent pool of researchers, engineers, physicists. So on paper, it looks a win-win situation, but the reality is quite different, as we know. So the reality is that, a few years ago, the Scopus, which is a scientific research database, it reported that Kenya is producing more researchers per 10,000 people than India. Then it was Mr. Narayan Murthy who came on the press and said that over the past 60 years, India has failed to do any breakthrough innovation, or any breakthrough ideas have not come from India. Now, on the other hand, if you look at the United States, whether it is the computer engineers in Silicon Valley, Google and Microsoft, there's a significant contribution from Indian engineers and researchers there. Google and Microsoft both are headed by Indians. If you see the Texas oil industry, petrochemical industry, there is a significant contribution of Indian entrepreneurs and Indian engineers in Texas. You move to the East Coast, where you have the Georgian belt of man-made synthetic fibers. You have a lot of Indian engineers there. You move up to New York, New Jersey, you have a lot of doctors. Again, a lot of doctors from India. So we have our own trained boys and girls who are thriving in one area, but in our own country, they are floundering around. the best of engineers are taken in India are taken by A, B, C. A is America, B is banking and finance, C is computers. So you have chemical engineers who are doing banking transactions. You have mechanical engineers who have joined finance companies. You have your industrial engineers who are doing coding now. So we have trained them for something, but we have not been able to provide them with the right employment opportunity, the right, I would say, monetary benefits so that they join manufacturing. Manufacturing is no longer the first choice for any engineer who's coming out. First, it is not glamorous. You have to dirty your hands and face on the shop floor. Second, it's not paying well. So apart from a few top-notch manufacturing companies who provide the ecosystem to these engineers, to our young engineers, whether it is in terms of challenging their abilities as engineers, as researchers, and as well as monetarily, most of us are not able to give a fertile ground for these kids to thrive. So again, I come back to the three distinct islands that exist in the country, and all these three islands are disconnected. A billion people who want to improve the quality of their life, a vast talent pool of tech graduates who want a work environment that will that will challenge their technical innovations and spirits, and a large number of SMEs looking for new opportunities. Now, it is up to us as industry, as academia, as policymakers to connect all these three islands. If we are able to connect these three islands, we'll have a win-win situation for the people, for the industry, as well as for the country. So, any discussion on research, any discussion on manufacturing is not complete if we don't talk about China. So China in itself is, for long, it was not predisposed towards research and development, towards R&D. It was primarily a manufacturing country. And they took arbitrage on the low wages. They had a vast working force, and they took an arbitrage that our labor costs are lower, and they grew the industry on that. Even China realized 5 years ago that they cannot thrive and continue just by this arbitrage on low labor cost. So and now we are in a situation where after 25, 30 years, even the Chinese are saying that we cannot, we are not competitive when it comes to manpower, because countries like Vietnam, countries like India, wages are much lower. So while India spends around 0.9% on R&D, China 5 years ago was spending 2% on R&D. We don't know the latest figures. They have vastly ramped up their investments in R&D. And now if you see whether it is robotics, whether it is 3D printing, solar power, artificial intelligence, material sciences, everywhere they're challenging the US, which has been a technological superpower till now. So just by pure play concentration on manufacturing, we will not be able to survive, because then we are, as we say in Hindi, doing kuligiri. There has to be an element of R&D, and R&D does not pay up quickly. As a businessman, a lot of times even I think that this is just a dead investment. When will it pay? But when it pays, it does pay. Now again, any technological discussion, whether it is based on plastics or anything, is not complete if we don't get the world's top innovation company, Apple, in the discussion. Can you imagine if Apple had not produced the iPod? The whole range of products would not have come in. And they produced the iPod when music was free. You didn't have to pay for music. There were much cheaper devices available. And Apple came out with a product where they said, you know, not only have to buy this expensive device, you also have to pay to buy the music and listen to music. So commercially, it did not make any sense, but it was pure innovation that they did, the ecosystem that the user experience that they made, that all the other technologies died away, and now only Apple exists. And that was the fountainhead. The original iPod, humble iPod, was the fountainhead for all the technologies thereon that Apple has developed. So, on the face of it, R&D might look as a dead investment, you know, but it will always pay. And we have to partner up with the academia, because we are the industry. It will be doing a great disservice to ourselves and the country if we ignore this vast asset that we have in the country, which are our research institutes, which are our engineering colleges, the researchers and engineers. There's a lot of good work that is happening here. Personally, I've been mentoring students and startups at IIT Delhi. There's an organization, industry interface at IIT Delhi, that is called FITT. This was started in 1992, inaugurated by the then Home Minister and Dr. Pranab Mukherjee. Then what the objective of this organization is, it's an interface between industry and the researchers at IIT. So we as industry, we go in, we mentor the young students, the PhD students, the engineers. They use our network, they use our time, they use our worldview. And then once they start the startups, and then we contribute monetarily or through our industry network to encourage them and to help them flourish. So these small models should not be existing in isolation at top-notch engineering colleges. These have to be nurtured and replicated and xeroxed across the country in various research institutes, various engineering colleges, various institutions like NCL. At ATIC, we have been working with CPET quite a bit. CPET has been instrumental in training our engineers, setting up our research protocols, doing the initial hand-holding for us. Till today, they continue the training and the testing part for us. So that was all from me. And again, I'll end with the three takeaways that I wanted you to have. That what got you here will not get you there. You have to think of something else. You have to recalibrate your approach towards manufacturing, towards R&D. You have to partner up with research institutes, with the researchers, to make something which is a little more than just taking an arbitrage on manpower. The low manpower cost will not last long. If the Chinese, with an autocratic political system, with the entire infrastructure that they have in terms of population, in terms of industry base, they could not sustain manpower cost at a low level for so long. India is a democracy, it's a noisy democracy. We are not yet there where the Chinese are. They are 5 times bigger than us. We should not expect to thrive on the basis of manpower cost. We say a lot that we'll bring manufacturing from China into India and we'll compete with China. I'll just give you an example of a company called Foxconn. It's a Taiwanese company which has 12 factories in China. It has factories in Brazil, Mexico, and India, also in Eastern Europe. One of the largest factories in China is in Shenzhen. It has more than 250,000 people working in it. It has its own hospital, its own mall, its own community center, 4 swimming pools, restaurants, cinema theaters, fire brigade center, its own railway station. So after doing all this, Foxconn is the manufacturer of iPhone. So it's a pure play manufacturing unit. There's no research happening at Foxconn. After doing all this, they earn only 3.2% on every iPhone product that is sold. Japan, which provides the technology, earns more than 30% on every iPhone that is sold. South Korea, which supplies the touchscreen technology to Apple, makes 12% on every iPhone that is sold. So it is not the manufacturing that we should be targeting. It should be the research-based manufacturing, innovation-based manufacturing that we should be targeting. That is where the money is. So that's it from me, everyone. I hope you'll be all looking for your competitive blue oceans after this. And me and Dr. Chikkali are there to take your questions. Thank you so much.
Thank you, Vikramji, for your insightful and very wonderful inspirational talk on affordable technology and the unexplored realm between Jugaad and exotic. Now we'll be taking the questions from the members. Kunal, please go ahead.
So thank you so much. So we have a question from Mr. Chikkali, from Mr. Jayesh Ramya, where he's asking from when can we get the list of technologies available to disperse to SME in plastic processing sector on regular basis?
Yeah, so I think NCL has a dedicated website. It is called, I can share the website details with you, where all the technologies that NCL has are listed. Okay, even CSIR for that matter has a dedicated website technologies. I will share with you. NCL has another part. It is called NCL Venture Center, where we have about 70 startup companies. Okay, some of those are actually run by the scientists ourselves. So we have some of our research going into startup. Okay, we mentor them, and somebody else is the CEO of that startup. So in NCL we have something called NCL Venture Center, where about 70 startups are hosted at any given time. And NCL Venture Center actually also does a lot of outreach to industry. So all the technologies that NCL develops, they try to market them. There is also a separate website for that. I will share that also with the editor.
Thank you so much, sir. So we have another for you coming from Mr. Ankur. He is asking for kindly share the details of contact person for sending a proposal for technology validation.
Okay, so I think see, NCL has something called Business Development Division, which actually looks at queries and other things. But the final call usually is taken by the respective scientist, because a scientist has to say whether he will be able to deliver that or not. Okay, so if you look at NCL website, you will get a Business Development Division and you will get their contact details. But if you want, I can send it. No issues.
Thank you, sir. Thank you so much.
Dr. Chikkali, if I may ask a question, more than a question, it's a discussion that I see there's a lot of focus in India on researchers and PhD students to go in for a patent to publish their research. Now, as I understand, once you publish your research, it is available in the public realm, and I know for sure that a lot of companies and countries keep an eye on these research papers because they get a lot of material from these research papers, which ideally should be the IP of the researcher himself. Secondly, on the patent front, what do you see as the future of the patent regime now that the technology, a patent gives you protection for 20 years, but now what we are seeing, the technology obsolescence is happening within 5 years. So by the time your patent is applied, it is granted, the product life cycle is already on the downward cycle to moving towards obsolescence because some new other technology is coming up. So I'd like to have your views on these two subjects, sir.
Yeah, I think as you rightly said, once you publish, okay, you can't do anything. Anybody who can reproduce that can start manufacturing, and that's how a lot of our pharma industry survives. Okay, we wait until the patent expires, and immediately we start producing because we have cheap labor. Okay, but that is only you have to play with cost, nothing else. And there is no technology, nothing. You are able to make it, and then you are able to sell it. You can make it. Okay. So most of the research which is not patented goes into all these kind of criteria. Unfortunately, I think in India there was not much of an emphasis earlier, but I think when Dr. Mashelkar became the Director General of CSIR, he said that he said three P's. One is patent, publish, or perish. Okay, so if you don't patent, you will perish. Okay, and then once you patent, you can publish. Okay, so that is what NCL follows. We have a very strong IP group, intellectual property group. We have internal exhibition every year, which is basically for students, PhD student. They have to display posters, and this IP group goes through all the posters, saying that whether they have filed the patent. If they have not filed, they write to the scientist saying that please file this. Okay, so most of us, where we feel that there is a value, okay, we file a patent and then afterwards we publish. The timeline for NCL is about 60 days. Once I submit the draft to my IP group, it goes to Delhi and then they file a patent. This takes about 60 days. In these 60 days, I can think of which journal I have to submit my paper and other things. And then after, once I get the number, I can submit. But once I have filed patent, nobody else can use that research. Okay. Now, commercialization of that patent is a big issue, and this is not really only in India, but globally it is. Okay. Even Harvard and MIT, if you look at their success, I think about 5%. That means if you have 95 or 100 papers, only 100 patents, about 5% is what you can actually get value. Okay. Others are just to protect it. I will give an example of ultra high. Okay, so when I started this research around 2012, in India there was not even a single patent on this. Okay, abroad there were some patents, but now if you look at on ultra high, Reliance has 50 patents. I have only 3 patents. Okay, so the way is to protect it. It is not that you file one patent and you sleep. Okay, you have to keep track who else is doing what, and then you have to back your patents. Okay, that is what Reliance is very good at doing. That. Okay, so they file first patents and then they keep backing it all the time. Okay, this has been done by all these technology licensors. For example, Reliance has technologies from British Petroleum or Shell or whoever. It is not that they have filed a patent in 1970 and then they are not doing anything. They keep filing all the time. It comes with little cost, but then you are a major player and you can recover those costs in this technology licensing. For example, in polyolefins, the technologies are so old. I mean, Ziegler did it in 1953, right? His first patent. Okay, now it's about 70 years. But still, you have technology licensors. Why is that? Those companies who licensed Ziegler's patent, okay, he licensed it to 20 different companies. He made so much fortune that his research institute was running on that money for 20 years. He even donated 4 million Deutschmarks to people who were in non-profit business. So he made so much money. After that, these companies who licensed the first patent kept licensing. For example, the Italian Montecatani. Now this company is no more there. It has been taken over by many different companies. One of Leondel Basel. Okay, so Leondel Basel has very strong patent portfolio, and they are technology licensed in polyethylene and polypropylene. In India, many of our companies have license from Leondel. Okay. So I think it is not about just one patent. Okay, you have to file the first patent. Once you know that it is going to be commercialized, you have to back your patents. Okay, you know where the research is going to go and what different you can do, and that you keep backing. Okay. Did I answer your question?
Yes. So my next natural question would be: is there in the Indian research ecosystem pressure on the researchers to file patent, to publish papers, and how do we transfer the focus from just pure play publishing and patenting to commercialization? How do we get the industry involved with the researchers?
Yeah, so I think getting involved with the researchers, see, the Indian industry initially. So if you look at CSIR, why CSIR was created, first of all, okay, the very reason was those our founding fathers, they felt that India cannot even make a color, okay, to color our fabric. Okay, in 1950s we could not even make a color. Okay, so they said that the mandate of CSIR is to actually help industries, Council for Scientific and Industrial Research. Okay, so it is very clear for CSIR that wherever industry requires, okay, we should help them. Now, in what terms, in what ways, it depends on which kind of industry it is. And CSIR has 38 laboratories, and these are in different domains, starting from constructing a road. Okay, we have a road research organization. Can you believe? Even today we have that. Okay, so it varies depending on which domain the industry wants CSIR's help. We do it in NCL is doing in chemicals. For example, I will give you one example. When I joined in 2012, NCL licensed a technology called ATBS. It's a monomer for making a polymer. Okay, ATBS is acrylamide tertiary sulfonic acid. It's a monomer. Okay, this was licensed to an Indian company. The company started with 2 tons per day. Okay, per annum. Now, if you look at today, this company is making the world's largest quantity of ATBS. This is the only product India makes more than China. And all of this is exported. There is no polymerization company which takes ATBS and polymerizes in India. This is all exported. And this company is Vinity Organics. Okay, and the technology was given by NCL. So there are such technologies that NCL has delivered, depending on who wants in which areas and whether we have the bandwidth and expertise in that. That's one. Biodiesel is another one. NCL has recently given it, and this is not to any Indian company, but an American company has licensed this. And there is, I think, 180,000 tons per annum plant running in US.
Okay.
So this,
Yes.
so in NCL, as far as CSIR is concerned, I think there are defined ways. Okay, we have defined ways to work with industry, work with the multinationals, work with SMEs. Okay, there are defined ways. Multinationals, we always have to go to our headquarters. I mean, if I want to take a project from, let's say, GE, okay, the NCL director has no authority to allow it. Okay, the DG CSIR has to allow it. I mean, we file all the papers, but it goes to Delhi, and then it is cleared from different ministries, not just Department of Science and Technology. This has to do with our strategic sector, our relations with those countries, and many other things. It takes little time, but we can still do with MNCs. With Indian industry, the call is taken at national. I mean, at the lab level, the director of the lab is allowed to take a call. If you look at IITs or our universities, unfortunately, I think there is a lot of gap between they publishing papers. Okay, they do it because I think their promotions and many things are depending on how many papers you have published and so on.
Exactly. Yeah.
This also happened in China. You know, China. If I publish a paper in Journal of American Chemical Society, China used to give $1,000 US. Okay. In India, fortunately, we did not do that. Okay, otherwise there were a lot of bad consequences of that. China has realized it now. Okay, but I think there a little bit of help is required, whether from because the universities are run by states, and all the states do not have good financial muscles. They feel that it is only for education and research is not really required. Only because some UGC makes some rules that they have to publish some paper, they keep publishing. For CSIR, there is no pressure either to file a patent or to publish. Okay, the aim is to serve the mandate. The mandate is to help industry, whether by publishing paper or filing patent or doing consultancy or doing testing, whatever it requires, we do it.
Okay. Thank you, Dr. Chikkali. So the genesis of my question was a conversation I had a few years ago with a German gentleman, an R&D engineer. And he said, I don't know why in your country, all your researchers, they keep publishing papers, all their research is available online. So this should be protected. This should not be given out for free to people.
Yeah, so I think so that ecosystem is not there. See, publishing a paper is a very different thing than filing a patent. Okay, you have to file a patent that nobody else would be able to file in that domain. Okay, and that requires very different expertise than just publishing a paper. Okay, so I think that ecosystem is not there in our universities and in many places. Even for example, I think the former director of NCL happens to be in the board of JNCSR, which is one of the reputed institute in India. In 2014, they were asked to submit proposals for technological developments. They were doing fundamental science all the time, and suddenly they were asked to do this. They did not even know how to file a patent. Even ICERs, we have 5 ICERs today. If you go and see how many patents they are filing, they are publishing hundreds of papers, but patents maybe 5 or 10. Okay. So I think that culture is not there. That culture is very much there in the US. In Germany, I would probably disagree with you what you say. Okay, because I have done PhD and have spent 10 years there, and I think I know a few things. For example, in German system, when the professor is funded, he's funded from the states. Okay, and the mentality there is that okay, he's getting free money, right? He did not do anything except being teaching. Okay, for research also there is something called Fonds der chemische Industry. Okay, that means the German chemical industry feels an obligation, says that we are working because somebody else is producing the manpower, right? So we have to give back to them. So they collect a lot of money from different industries, they put in a pot, okay, and hand it over to an organization or a body, which is then distributed among the German professors without giving them a final target whether you should do this or that. They only believe that this money is given for research and that should serve the society. Okay. So this is what the German university mostly do. There are different organizations, by the way, in Germany. For example, they have built the whole chain. It is the research that is done at the university, but if you want to scale it up, they have different institutes. For example, Fraunhofers are there. Okay, Max Planck, they do fundamental science, but if they want to connect to a product, okay, there are different organizations. There is Fraunhofer, there is Leibniz Institute, and these are something like CSIR. For example, CSIR has 48 labs. There are many Fraunhofers in Germany. There are
So
many Max
in
Planck.
effect, is the Indian system more in line with the German system or the US system? And which one should we be following, ideally?
I think we should not follow any of this, neither China. Okay, like you said, becoming a manufacturing hub is not a sustainable solution. I think what the West has realized, maybe I would say Europe, not just Germany, is to look at sustainable developments. Okay, long-term developments. See, Germany has companies, or even Netherlands. Look at Shell. Okay, if you look at the Shell's balance sheet, it is more than Netherlands' balance sheet. Okay, so such a company which has a balance more than the country. Look at Philips, it's again Dutch. And what is the size of Netherlands? It is a district in Maharashtra like Ahmednagar. Okay, size of Germany is equivalent to Maharashtra. Look at the companies, Bosch or for Mercedes, many companies. Okay, how do they manage? I think they manage because they create knowledge and knowledge-based economy and not manufacturing-based economy. I think they have went through the manufacturing base. They have realized in 1970s that this is not the solution. Okay, and that's why they have reduced that. Many German companies have plants in China or in India. Why do they do it? Okay, they know that if they can do it in Germany, they will be spoiling their nature, they will be spoiling their environment. Okay, and of course the costs. Okay, now if you look at BASF, which is the biggest chemical company, they have a plant on Ludwigshafen, end-to-end plant, okay? But there is zero waste generated. Every waste that is produced is created into, turned into a product.
Right, and
So,
BASF, I think, would be 80 or $90 billion company right now.
yeah. So I think that is how we should look at. We should not look at throwing things. It doesn't actually serve a purpose. Whatever we want to throw, it should be converted into some or the other form, which can be used again. For example, I think India is talking about CO2 sequestration, and this is not just India. Globally, people are talking about, because we produce a lot of CO2. it should be used as a raw material. Same thing with plastics. We produce so much worldwide. Can we use it as a raw material and make other products?
Great. Thank you, Dr. Chikkali. I think you have more questions. I think there's one from Arvindji. Is NCL doing any R&D on all polymers or specializing in a few of them? Is NCL working on PVCs?
Okay, so PVC again is a kind of polyolefin, I would say, because it has a olefinic double bond. NCL has done some work on PVC earlier, but if the industry wants, we will definitely like to see what the industry wants. As of now in NCL, there are various domains. We have different departments. One of them is called Polymer Science and Engineering, and I'm part of that department, where we have both polymer scientists, means chemists, and polymer engineers who look at processing properties, melt rheologies, properties, and so on. Okay. So I think definitely it's within the mandate of the Polymer Science and Engineering Division at NCL.
Great. Thank you, Dr. Chikkali. Any other questions? Srivashi,
We have
over
a
to you.
question. So we have a question for you.
Acha.
That's from Mr. Karthik. He's asking, can you share a few recent trends in sustainable packaging solutions for overcoming the single-use plastics?
So, Karthik, a few pointers on that.
No,
One is,
thank you very much, Dr. Yeah, thank you.
I guess Arvind sir is trying to say something. Chairman sir,
Arvind, we're not
No,
able to hear
it's
you.
okay. It's okay. Go ahead,
Okay.
Vikramji.
So, a few trends. One is mono packaging. You replace multi-layer with a single polymer structure. So, your cap, your bottle or tube
Please go ahead.
will be made of the same polymer. And the other is trying to recycle the multi-layer structures, the 3-layer, 5-layer, 7-layer structures. There has been a lot of success in the multi-layer recycling in terms when nylon is involved. Wherever PET is involved, there's a lot of work still going on, but green shoots of success have been seen in that technology. So that's my submission for your question, Karthik. Anything specific you would like to ask, please feel free to connect with me offline.
So we have a last one coming in from Mr. Varun. How do we tie up with the with this academia? Can they share in the WhatsApp group? And can we also focus on soft power and patriotism?
I missed the question. What was, how do we tie up with the academia? Can they be shared in the WhatsApp group? So Varun, Dr. Chikkali is here. He's given you, now you have a contact point in NCL. If you need contacts in IIT Delhi, I'll be happy to connect you with their departments. And your next question is, can we focus on soft power and patriotism? So yes, as far as patriotism goes, focus on increasing the country's GDP. Do whatever we can. We should do whatever we can to provide the employment, provide the taxes, and make India into an industrial base. As I said in the beginning, there is no country which has become powerful, which is on the global stage, which is not industrialized. Your industry is the base for everything. That's my submission for that, your question, Varun.
Thank you, sir. Thank you so much. We don't have any other question on this. Sir, over to ED sir for this now.
Okay, thank you. Yeah.
Excuse me, sir. Can I go ahead?
Yeah, please go ahead.
Yeah. So this is Professor Arun Islur. I'm from NIT Surathkal, Karnataka. And a small query with Dr. Chikkali ji. Sir, some 3-4 years back, Professor Dr. Ullas Karul from Polymer Division of NCL. So he developed oxygen concentrator, as per my remembrance. So any commercial production has been started. Just for a curiosity, I'm just asking because of the acute shortage of the oxygen everywhere. Can you please share about that?
Yeah, see, I think Dr. Karul will be the best person to comment on this, but I will share whatever I know. Okay, so I think NCL tied up, like I said, NCL can't be an industry. So NCL tied up with this Bharat Electricals, and they started manufacturing these oxygen concentrators in the first wave itself, and they have given it to many hospitals in Pune. So this is the update, and NCL in the second wave, NCL has developed. I mean, this is based on IIP's technology, but we implemented it and installed in different hospitals in Pune. This is based on this pressure vacuum swing technology, where you take air and there are absorbents which selectively absorb only oxygen, and this oxygen is given to the hospital. So this NCL has done recently.
Okay, sir. Thank you so much. Thank you.
Well, this is the last part. Yes, the vote of thanks on behalf of the Plastic Export Promotion Council and my own behalf. I would like to convey my sincere thanks and gratitude to both the speakers, Dr. Chikkali and Mr. Bhadauria, for their insightful talk on an apt topic, collaborative R&D and its relevance in the present world. Of course, it is very much true that for a sustainable development, we should move from a transaction-based economy to a knowledge-based economy. I hope the members present at the webinar will think of the usefulness of this subject. As far as Place Council is concerned, in our endeavor to engage with our members, we will be continuous to organize more and more industry-relevant webinars for the benefit of the industry. I'm thankful to our chairman, Sri Arvind Goenka, vice chairman, and other CEO members who have joined us today in spite of their busy schedule. I also thank SRE members of the Plastic Association who managed to join us today. I also thank Ms. Sangeeta Iyengar for coordinating with the speakers for today's webinar. I'm thankful to the entire Secretary of Place Council for organizing this webinar. Thank you all. Have a good day.
Thank you, Dr. Chikkali. Thank you, Vikram. Thank you, friends.
Thank
very,
you.
very insightful. Thank you very much. Thank you.
Thank you. Thank you.
Thank you so much.